Hello everyone, welcome to Wings of Physics. Myself, Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our one-shot lecture series and the chapter Thermodynamics, and this is the one-shot lecture part 2. Let us start. First, we have to study the first law of thermodynamics. What is the first law of thermodynamics? Consider a thermodynamic system. This is a thermodynamic system and it is fitted with a massless, movable and frictionless piston. Suppose Q is the heat supplied to that system. This is Q is the heat supplied to the system. When heat is absorbed by that system, then intermolecular distance between the molecules of this ideal gas that gets increased, and due to that the increase in internal energy is there. Delta U, that is increase in internal energy, and its formula is NCV dt. Now due to that, when intermolecular distance goes on increasing, then piston move upward in this manner, and when the piston move upward, some displacement is there, some force is there, also displacement is there, and therefore the W is the total work done in this process, and that total work done, that is nothing but P delta V, and therefore the mathematical statement of first law of thermodynamics is that Q, that is equal to summation of change in internal energy and the external work done, and this is the mathematical form of a first law of thermodynamics. One MCQ can ask in this article, that is first law of thermodynamics is law of conservation of dash dash. That dash dash, that is nothing but energy, because heat is a form of energy and that gets converted into the internal energy, that is also energy, and work done can store also in the form of energy, and therefore first law of thermodynamics, that is nothing but the law of conservation of energy. Understood? Now we have to study about thermodynamic process, and that definition of thermodynamic process was asked in last year board exam. Thermodynamic process. Thermodynamic process. Thermodynamic process. Consider a system, and this thermodynamic system having initial values. Pi is the initial pressure, Vi is the initial volume, and Ti, that is the initial temperature. And now the initial values that goes on changing from Pi to Pf. Then Pf is final pressure, Vf is final volume, and Tf is the final temperature, and that is called, this is the initial state and this is the final state of the system, and a thermodynamic process is defined as, this is a procedure. Thermodynamic process is a procedure due to which the initial state of the system that changes to the final state of the system, and this is the definition. And we have to study the different types of thermodynamic process. Before studying this thermodynamic process, we have to study about path. What is the path? What is the path? Path. What is the concept of path? When there is a changes in system, initial change to final change of the system, at that time the system goes through some intermediate series of changes. Suppose this is the initial state, A is the initial state and B is the final state of the system. Now this initial state to final state, the Pi is the pressure, initial pressure, Pf that is the final pressure, then the Vi is the initial volume and Vf, that is the final volume. We know that on x-axis volume is there and on y-axis pressure is there. Understood? Then the initial coordinates of this point A, that is Vi, Pi, and coordinates of this point B, that is Vf, Pf. Then when initial state of system that changed to final state, it passed through a series of intermediate changes. And when this intermediate series of changes that is plotted on a PV diagram, this is a PV diagram, and when this series plotted on a PV diagram, that is called as a path. First path, this is the first path, first change. This is the second path and this is the third path. This is the third path. Okay. Now we have to prove that the work done, I already told you in first part of this lecture, that is heat and work, they are path functions, and internal energy, that is state function. And now we have to prove that the work done, that is a path function, means it depends on path. Then this is the path first, this is path second, and this is path third. Now we have to calculate the work done during path first, work done during path second, and work done during path third. Now this is the case. Now in this case, volume goes on increasing and pressure goes on decreasing. When volume goes on decreasing, we already studied that when volume goes on increasing in this manner, then expansion is there, and when expansion is there, work done is always positive. Means in this case, area under the curve, expansion is there, and area under the curve, that gives you the work done. This is the work done, and that is always greater than 0, that is nothing but the positive. And this is the value of area under the curve, that gives you the value of work done, and this is the work done during path first. Then second case. Now this is the case. During this change, volume goes on increasing in this manner, and volume goes on increasing means positive work done is there, and during this path, then the volume remains constant, pressure goes on decreasing, and when volume remains constant, V is constant, change in volume, that is always equal to 0, and during this path work done is 0. But during this change, this is the work done, area under the curve, that is the work done, and this is the value of work done, and that work done is also greater than 0, that is work done, that is nothing but positive work done, and this is the work done during the change initial state to final state of the system, and that is positive work done, or that is the work done during path second. This is the work done during path first. And case third, this is the case. In this case, the system goes in this manner, initial state to final state. Now we know that during this path, means this is the pressure goes on decreasing, but volume remains constant, means during this path work done is 0. But during this path volume goes on increasing, and area under the curve, that gives you work done. Again, this is the value of work done, but this value is expansion is there, work done is greater than 0, or work done is positive. Means as path goes on changing, value of work done, that goes on changing, that is different. Work done is different in these 3 different cases, and therefore we can prove that the work done, that is a path function. It depends on path. As path goes on changing, work done also goes on changing. And in this manner, when a system there is a change from initial state to final state, at that time there is a series of intermediate changes, and when this series is plotted on PV diagram, that is called as a path. This is path first, this is path second, and this is path third. And in this manner we can explain the term path, as well as we can prove that the work done, it is a path function. Understood? Now we have to study the classification of different process, and this article is very important, because in terms of the competitive exam, question always asked on this process, and therefore we have to study all the process in very detailed manner. In your theory exam, always question is there on this article, and therefore we have to study the classification of thermodynamic process. First process, that is reversible process, and second process, that is irreversible process. And we will study these two processes in the form of difference. First is reversible process and irreversible process. Irreversible process. Now consider one example. Suppose ice is there. This is the ice, and it melts into the water. This is the water. Ice gets converted into the water. When ice melts, it gets converted into the water, and when water freezes, at that time water freezes, it can again form into the ice. Means if we reverse the direction of process, then initial state of the system that can restore, and that process is called as reversible process. Understood? And therefore, what is the definition of reversible process? A thermodynamic process in which initial state of the system that can restore, that process is called as the reversible process. Understood? And therefore, initial state that can restore. Initial state that can restore. Restore. Now here, what is irreversible process? In this process, initial state that cannot restore. Cannot restore. Cannot restore. For example, a burning of candle is there. Then initial state we cannot form that candle once again. Means initial state cannot restore. Puncturing of a tire, puncturing of a balloon, that is also irreversible process. When we rub our palm, at that time heat is produced. We cannot restore that heat once again. Means all these are the examples of reversible process. And what is the definition of reversible process? A process in which initial state that cannot restore, that process is called as irreversible process. And this is the first point. Then second point. PV diagram. Now this is the path. During the change of system from A to B, Pi is initial pressure, Pf is final pressure, Vi is initial volume, Vf is the final volume. And this is the PV diagram. Now this is the case initial to final state, and this is the case final to initial. Means in this case, in reversible process, the forward path and backward path, that is the same. And in these cases, the forward path is in this manner and reverse path in this manner. Means that cannot same. Pi is initial pressure, Pf is final pressure, Vi is initial volume, Vf is the final volume. And this is the PV diagram for irreversible process. Initial path and final path, that is not same. Third case, this is the PV diagram for reversible process. And third difference, this is the PV diagram for irreversible process. Then the reversible process is very slow. It is very slow process. And due to that, no loss of energy. No loss of energy. This process is very fast process. बघा, बर्फाचं पाणी होणं किंवा पाण्याचा बर्फ होणं ही खूप हळूहळू घडणारी प्रक्रिया आहे आणि त्याच्यामुळे एनर्जीचा लॉस रिव्हर्सिबल प्रोसेसमध्ये होत नाही. पण बघा, टायर पंक्चर होतं, आलं लक्षात, किंवा आपण हात एकमेकावर घासतो, ही फास्ट होणारी प्रक्रिया आहे. आणि इथे आता बघा, जेव्हा आपण दोन तळवे आपले एकमेकावर घासतो, रबिंग ऑफ पाम इज देअर इज ए फ्रिक्शन अँड ड्यू टू फ्रिक्शन देअर इज ए लॉस ऑफ एनर्जी. Puncturing of a balloon, puncturing of a tire, due to that also there is a loss of energy, and therefore the fourth point, that is a fast process. Irreversible process is a fast process, and due to that there is a loss of energy due to the friction or other dissipative forces, due to the friction or other dissipative forces. Understood? And next point, this is ideal process. This is ideal process. And this is the real process. This is real process. This is real process. And last point, that is the example. Just now we studied that the ice gets converted into the, when ice melts, it forms water. Then water gets converted into the ice. Boiling of water, condensation of steam, all are the example of reversible process. Melting of ice, freezing of water, boiling of water, condensation of steam, all are the examples of reversible process. And just now I told you, what are the examples of irreversible process? The burning of candle, puncturing of a balloon, puncturing of a tire, rubbing of our palm, all are the examples of irreversible process. And in this manner, these first two processes we can explain. Okay, I hope all of you understood this difference very well. Then next process, that is isobaric process. Third process, that is isobaric process. Isobaric process. Isobaric process. How to keep in mind this process? Iso means same, and bar, that is unit of pressure. It is unit of pressure. Means a thermodynamic process in which pressure remains constant, and when pressure remains constant, then we know that the Charles law, when pressure is constant, P is constant, then volume of given mass of a gas, that is directly proportional to the temperature, and this is the Charles law. And equation of state for this process, that is nothing but whenever direct proportion is there, then division of these two variables, that always remains constant, and we can say that V1 T1, that is equal to V2 T2, that is equal to constant. This is equation of state for the isobaric process. Understood? And boiling of a water at constant pressure, suppose water is there in this, and that boiling of water at a constant pressure, that is the best example of the isobaric process. And where is the use of this process in a meteorology department? certain graphs are there, and that graph showing that a region where pressure remains constant. Understood? That is the use. Then isobaric process. We have to study the thermodynamics of this process. Now, we know that first law of thermodynamics, Q, that is equal to change in internal energy plus external work done. Now, suppose this is a system and Vi is the initial volume and Ti, that is the initial temperature. Just now we studied that in this process the P constant means V is directly proportional to T. As temperature goes on increasing, volume goes on increasing. Now this is the final volume, and TF, temperature goes on increasing, means the TF, that is greater than Ti, therefore volume Vi, that is also final volume Vf, that is also greater than initial volume. Means as temperature goes on increasing, volume also goes on increasing, and therefore we know that Q, heat is supplied to the gas, that is nothing but delta U, internal energy, that is NCV dt, and work done, that is P into delta V, that is W, that is equal to P delta V, but P delta V, and we have to write down this P delta V, that is nothing but NR delta T. We can write this P delta V, that is equal to NR delta T, and therefore NCV dt plus NR dt. Now this dt, that is nothing but change in temperature, and change in temperature, that is nothing but Tf minus Ti. Tf is final temperature, Ti is initial temperature, and the increase in temperature or change in temperature, that is nothing but Tf minus Ti. If we substitute the value of this one, Tf minus Ti plus NR Tf minus Ti, then the heat supplied to the system, then NCV plus NR, that is taken as common, and in this bracket we can write Tf minus Ti. We know that the Cp, that is equal to Cv plus R, and therefore if N is taken as a common inside the bracket, we can write Cv plus R, and this Cv plus R, that is nothing but Cp, and therefore Q, that is equal to NCp, and in this bracket we can write Tf minus Ti, and this is the thermodynamics for the isobaric process. And N, that is number of mole, Cp is specific heat of a gas at constant pressure, Cv, that is specific heat of a gas at constant volume, and R is universal gas constant. Now what is the PV diagram? PV diagram. Now we know that volume is on this x-axis, pressure is on this y-axis, then PV diagram, pressure remains constant but volume goes on changing, means this is initial volume, this is the Vi, at that time temperature is Ti, as volume goes on increasing, temperature also goes on increasing, or alternately we can say that as temperature goes on increasing, volume also goes on increasing, and Pi is the pressure that remains constant, and this this figure or this PV diagram, that is called as isobar. A PV diagram, a straight line curve that is always parallel to, in isobaric process, the curve in PV diagram a line parallel to x-axis that gives you the isobar. This is the isobar, and in this manner we can explain the isobaric process. Understood? Now next process, and that is very simple process, that is isochoric process. Isochoric process. Isochoric process. Isochoric process. Again, iso means same, and core means inner part of the system. Means inner part of the system, that constant, that is nothing but volume. Inner part of system, that is volume, means volume remains constant. At that time the process is a isochoric process, a thermodynamic process in which the volume of the system that remains constant, that process is called as isochoric process, and it is very easy process because we know that as volume remains constant, V is constant, then change in volume, that is equal to 0, and we know that work done W, that is equal to P delta V. We can write in this manner dV. If dV that is equal to 0, then work done that is equal to 0, and when work done that is equal to 0, Q that is equal to delta U, means work done that is nothing but all the heat supplied to the system is used to increase its internal energy, and we know that formula for internal energy, that is NCV dt, and CV is specific heat of a gas at constant volume, and this is the heat supplied to the system in isochoric process, that is equal to this one, and this is thermodynamics of a isochoric process. Now in this case, which law is there? When volume remains constant, pressure is directly proportional to temperature. Therefore, the Gay-Lussac's law is there. And the pressure cooker, that is the best example of a isochoric process. Or heating of a gas, second example, heating of a gas at constant volume container, that is the second example of isochoric process. Or diffusion of a gas in closed chamber, that is third example of the isochoric process. And P by T, that is equal to constant. This is equation of state for isochoric process. Or P1 by T1, that is equal to P2 by T2, that is equal to constant. This is the equation of state for this isochoric process. And if you have to draw a PV diagram, on x-axis volume is there, on y-axis pressure is there. If the volume remains constant, means this Vi that remains constant, then pressure Pi and Pf. Pi is the initial pressure, Pf is the final pressure, and this is called isochore. And when isochoric process is there, then graph is a straight line parallel to y-axis. आडवी रेषा आइसोबारिक प्रोसेस, उभी रेषा आइसोकोरिक प्रोसेस, आणि जेव्हा जेव्हा पीव्ही डायग्राम वर उभी रेषा तुम्हाला दिसणार आहे, डोळे झाकून त्यावेळेस वर्क डन काय येणार आहे तुमचं 0. अंडरस्टूड? अँड इन दिस मॅनर वी कॅन एक्सप्लेन द आइसोकोरिक प्रोसेस. अंडरस्टूड? नाउ नेक्स्ट प्रोसेस, that is isothermal process. Isothermal process. Isothermal process. Let me clean the board. Next process, fifth process, isothermal process. Isothermal process. Again, iso means same and therm means temperature. A thermodynamic system in which temperature remains constant. Then T is constant. Then delta T, that is equal to 0. And we know that the internal energy depends on a temperature NCV dt. If you write dt in this manner. If dt equal to 0, then change in internal energy is 0. Means if we substitute change in internal energy, that is equal to 0, Q that is equal to W for an isothermal process. Now temperature remains constant. Then we know that when temperature of the system is constant, pressure of the system that is inversely proportional to the volume, and that is nothing but Boyle's law. And therefore we can say that if we transfer this V here, and that is equal to constant, PV that is equal to constant, this is equation of state for the isothermal process. And if Pi is the initial pressure, Vi is the initial volume, and Pf that is the final pressure, and Vf that is equal to final volume, and that is equal to C, the constant C. This is the equation of state for this isothermal process, and in this process Boyle's law is there. Now what is the condition? A most important condition is that the boundary of the system that should be perfectly conducting boundary. This is the most important condition, so that there is an exchange of heat between system and surrounding. Understood? And this process is very slow process, and that slow process, due to that slow process, the system maintains its thermodynamic equilibrium. And now we have to define one term, quasi-static process. A process which occurs infinitesimally small or very slowly, that process is called as a quasi-static process. And when the changes are system occurs very slow, at that time we can say that system is quasi-static system. Understood? What is the meaning of quasi-static change or quasi-static process? When changes in system occurs very slowly, at that time system is quasi-static system. Okay? And isothermal process, it is a quasi-static process, and due to this slow process, a thermodynamic equilibrium that should be maintained by that system. We already studied in last lecture what is the meaning of thermodynamic equilibrium. Okay. Now we have to study the derivation for this work done. Now the work done, Q that is equal to W, and there are changes in the system, that is Pi is the initial pressure and Vi is the initial volume that goes on changing. Pf is the final pressure and Vf is the final volume. Then we know that work done during that process, Vi to Vf, volume goes on changing, P delta V. Now we know that here two variables are there and we cannot integrate the two variables, and therefore we have to substitute PV that is equal to nRT, that is ideal gas equation, and value of P that is nothing but nRT by V, and we have to substitute value of P in this manner. Then integration of within the limit Vi to Vf, then nRT by V into dV. Now this nRT, that N is the number of mole, R is universal gas constant, and T, that is the temperature of the system, and that is constant. And therefore, we can take out this constant outside the integration sign, then Vi to Vf, and derivative of integration of this dV by V, that is nothing but log of V. Therefore, W, that is equal to nRT, then ln V. This ln indicates that, always keep in mind that ln, that is nothing but log to the base E, and when log is there, at that time log to the base 10. In your book, wherever ln is there, that indicates that ln means log to the base E. Okay, then here Vf and Vi, then nRT. If we apply the limit ln Vf minus ln Vi, then that is nothing but W, that is equal to nRT log Vf divided by Vi. When subtraction is there in between log, that is nothing but division of these two numbers, and that is the work done. But we have to convert this log of base E into log 10, and we can write this equation in this manner, that is nothing but 2.303 nRT log, now this log indicates that log to the base 10 Vf by Vi, and this is, while solving the numericals, we have to use this formula, and this is the work done during isothermal process. Now from this formula, we can write Vf by Vi, that is equal to Pi by Pf. Rearranging this formula, we can write W, that is equal to nRT ln Pi by Pf, that is nothing but 2.303 nRT log to the base 10 Pi by Pf. Now, PV diagram for this isothermal change. PV diagram for this isothermal change. Pi is the initial pressure, Pf is the final pressure, Vi is the initial volume, and Vf, that is the final volume, and this nature, that is called as rectangular hyperbola. Rectangular hyperbola. Rectangular hyperbola. This is the nature of graph, and this is also called as, this curve is called as isotherm. It is called as isotherm, and in this manner we can explain the work done Q, that is equal to W, and therefore Q, that is equal to W in this case, and this is the isothermal for the thermodynamics for isothermal process. In this manner, we can explain in detail the isothermal process. Understood? And while solving the numerical, you must use this formula because you have to use log to the base 10. Okay? Next, that is the adiabatic process. Adiabatic process. Adiabatic process. Adiabatic process. Now consider a thermodynamic system, and in that thermodynamic system no heat enters or leaves through the system, means Q that is equal to 0, and that process is called as adiabatic process. What is the definition of adiabatic process? A thermodynamic process in which no heat enter or leaves through the system. And therefore, if we substitute the value of this Q that is equal to 0, delta U plus W, and that is nothing but delta U that is equal to minus W. Means if internal energy increases, work done decreases, or internal energy decreases, work done increases. या दोन्हींमध्ये 36चा आकडा. एक वाढलं तर दुसरं कमी होणार आणि एक कमी झालं तर दुसरं वाढणार. या पद्धतीने आता आपल्याला ह्या वर्क डन साठी डेरिवेशन ऑब्टेन करायचे आणि सगळ्यात लेंदी प्रोसेस किंवा मोठं डेरिवेशन हे कशाचं असेल तर ते ॲडियाबॅटिक प्रोसेसचं डेरिवेशन असेल. आणि महत्त्वाची कंडिशन, आयसोथर्मल प्रोसेसमध्ये जी बाउंड्री होती ती परफेक्टली कंडक्टिंग होती. ॲडियाबॅटिकमध्ये बाउंड्री असते परफेक्टली इन्सुलेटिंग. perfectly insulating boundary. Perfectly insulating boundary. This is the most important difference between the isothermal process and adiabatic process. In isothermal process, boundary is perfectly conducting, and in adiabatic process, boundary is perfectly insulating so that no heat enters or leaves through the system. याच्यामध्ये हीट येणार नाही आणि हीट बाहेर पण जाणार नाही, म्हणजे Q that is equal to 0, and when Q that is equal to 0, change in internal energy that is opposite to the work done. Understood? And now we have to obtain the derivation for this adiabatic process. Now for this adiabatic process, the equation of state is PV raised to gamma that is equal to constant. What is this gamma? Gamma is the adiabatic ratio. Adiabatic ratio. And that is nothing but Cp by Cv. Specific heat of a gas at constant pressure. It is a ratio of gamma, that is a ratio of specific heat of a gas at constant pressure to the specific heat of a gas at constant volume. And this is for monoatomic gas, it is 5 by 3, that is nothing but 1.66. For for diatomic gas, we already studied the value of gamma in KTG and radiation chapter, that is chapter number 3. Then that is 7 by 5, that is nothing but 1.4. For air, air is a diatomic gas and its value is 1.4. And for polyatomic gas, its value is the 8.6, that is nothing but 4 by 3, and that is nothing but 1.33. Now this is the gamma for monoatomic gas, this is the gamma for diatomic gas, and this is the gamma for polyatomic gas. Now we have to obtain the derivation for this work done in adiabatic process. Now, for initial state of system, we can write PIVI raised to gamma, that is equal to PFVF raised to gamma, that is equal to constant, and this constant that is nothing but C. Here also we can write this constant that is equal to C. Now, what are the examples of adiabatic process? The puncturing of a balloon, puncturing of a tire, that is the best example of adiabatic process. It is very fast process, and so that system does not get time to exchange the energy with the surrounding. Understood? Isothermal process is very slow process, and adiabatic process that is very fast process. Then now we have to obtain derivation. We know that W that is equal to integration of within the limit Vi to Vf P into delta V. Again we know that P and dV, these are the two variable, and we cannot integrate these two variable, and therefore we have to substitute the value of P, and from this equation P that is equal to C divided by V raised to gamma, and we have to substitute value of P that is equal to C divided by V raised to gamma in this equation. We can write Vi to Vf C divided by V raised to gamma into dV, and that is nothing but C is constant and therefore it is taken outside the integration sign. Vi to Vf is there. This V raised to gamma, that is nothing but V raised to minus gamma into dV, and we know that integration of x raised to n into dx, that is equal to x raised to n plus 1 divided by n plus 1. By using this formula, we can write this C is constant, then integration of this V, that is minus gamma plus 1 divided by minus gamma plus 1. Limit of integration is Vf and Vi. Now, W that is equal to, this W that is equal to, now C divided by this, we can write minus gamma plus 1, that is nothing but 1 minus gamma, and inside the bracket we can write Vf raised to minus gamma plus 1 minus Vi raised to minus gamma plus 1, and that is nothing but 1 divided by 1 minus gamma. Then this Vf can be written as 1 upon Vf raised to gamma minus 1 minus 1 divided by Vi raised to gamma minus 1. Understood? हे 1 upon केलं, याचे साइन काय झाले, चेंज झाले. Now this C that can taken inside 1 by, here C is there, here C is there. Now value of C, in this case we can write P of Vf raised to gamma, P of Vf raised to gamma, and in this case we can write Pi Vi raised to gamma. Then solving this equation we can write W that is equal to 1 by 1 minus gamma into bracket. Now this Vf raised to gamma and Vf raised to gamma, that gets cancelled, and Vf raised to minus 1, that becomes Vf into Vf raised to plus 1, and we can write Pf Vf minus Pi Vi. Okay, and in a systematic manner we can write Pf Vf minus Pi Vi divided by 1 minus gamma, and that is the value of the work done, and that is nothing but the minus delta U. Work done, that is equal to minus delta U. Now when pressure and volume is given, at that time we can write this formula, but when the temperature is given, at that time we know that PV that is equal to nRT, and therefore W that is equal to 1 upon 1 minus gamma, and here nRT, nR that is taken as common, but inside bracket when adiabatic expansion is there, then initial temperature is greater than final temperature. When expansion is there, temperature goes on decreasing, and when compression is there, temperature goes on increasing, and therefore when expansion is there, Ti is the initial temperature, and that is always greater than final temperature, and work done is positive. And for positive work done, inside bracket we have to write, here Vf is there, but we have to write Ti minus Tf. This is the formula for adiabatic expansion, and when adiabatic compression is there, at that time work done is negative, and we have to write this formula nR into bracket Tf minus Ti. This is for the adiabatic expansion, and for compression we can write the W that is equal to NR into bracket W that is equal to NR into bracket TF minus TI by 1 minus gamma. This is for adiabatic compression, because in adiabatic compression temperature goes on increasing. Understood? And in adiabatic expansion temperature goes on decreasing. And in this case work done is positive, and in this case work done is negative. Now the equation of state for this adiabatic process, different forms of equation of state for the adiabatic process are: first form is PV raised to gamma. This is equation of state. Second, P 1 minus gamma into T raised to gamma, that is equal to constant. This is second equation of state. And third equation of state, that is T into V raised to gamma minus 1, that is equal to constant. This is the third equation of state, and we have to use these three equations of state for adiabatic process in case of the CET, NEET or other competitive exams. You must remember that these are the three equations of state for adiabatic process. Okay. Now the PV diagram. The curve is more steeper. This, suppose two cases are there. This is the isothermal curve and this is the adiabatic curve. The curve is more steeper than the isothermal process. Pressure is here PI, PF, VI, VF, and this is the PV diagram for the adiabatic process. Understood? And in this manner we can explain the adiabatic process, or this is the derivation for work done in the adiabatic process. समजलं का? अतिशय विस्तृत स्वरूपात हे समजून सांगितलेलं आहे. मला खात्री आहे की तुम्हाला हे व्यवस्थित समजलेलं असेल. मग आता बघा, कॉम्पिटिटिव्ह एक्झामला तुम्हाला एक ग्राफ देतात आणि त्या ग्राफमध्ये नेचर विचारतात. या सगळ्या प्रोसेस किंवा एखादी प्रोसेस डिटेलमध्ये विचारतात. म्हणजे आजचा सेक्शन परीक्षेच्या दृष्टीने अत्यंत महत्त्वाचा आहे. आता बघा, समजा या पद्धतीने तुम्हाला ग्राफ दिला. हा असा दिला, हा असा दिला, हा असा दिला आणि हा असा दिला. मग हा 1 नंबरचा ग्राफ, हा 2 नंबरचा ग्राफ, हा 3 नंबरचा ग्राफ आणि हा 4 नंबरचा ग्राफ. मग आता काय सांगता येईल आपल्याला? प्रेशर इज हिअर, व्हॉल्यूम इज हिअर. पहिला ग्राफ काय सांगणार आहे? कोणती प्रोसेस? आयसोबारिक प्रोसेस. आयसोबारिक. हा काय सांगणार आहे तुम्हाला? आयसोथर्मल प्रोसेस. हा काय सांगणार आहे? ॲडियाबॅटिक प्रोसेस. कारण जो मोर स्टीपर असतो तो ॲडियाबॅटिक प्रोसेस असतो. आणि हा जो 4 नंबरचा ग्राफ आहे हा आयसोकोरिक प्रोसेस. आडवी रेषा आयसोबारिक, उभी रेषा आयसोकोरिक, मोर स्टीपर ॲडियाबॅटिक अँड रेक्टँग्युलर हायपरबोला आयसोथर्मल. हे तुमच्या परीक्षेच्या दृष्टीने हे अत्यंत महत्त्वाचं आहे. समजलं का? आता शेवटच्या 2 प्रोसेस आपल्याला पाहिजे, सायक्लिक प्रोसेस आणि प्री एक्सपान्शन. सायक्लिक प्रोसेस अँड प्री एक्सपान्शन. सायक्लिक प्रोसेस अँड प्री एक्सपान्शन. आता सायक्लिक प्रोसेस. एक मिनिट, आपण शाई भरू पेन मध्ये. आता बघा, सायकल. समजा या पद्धतीने हे झालं एक्सपान्शन, PI, PF आणि इथं VI आणि VF. ओके. जाताना प्रोसेस अशी झाली आणि येताना अशी झाली. आता बघा, दिस इज द इनिशियल स्टेट. व्हॉट इज द इनिशियल स्टेट? VI PI. आणि फायनल स्टेट VF PF. ज्या प्रोसेसमध्ये इनिशियल स्टेट ही परत होते, रिव्हर्सिबलमध्ये रिस्टोअर आणि इथं रिटर्न. बघा, ए थर्मोडायनॅमिक प्रोसेस इन विच सिस्टीम रिटर्न्स to its initial state. That process is called as cyclic process. आता बघा, जाताना थर्मोडायनॅमिक काय झालं? एक्सपान्शन, व्हॉल्यूम वाढलं, प्रेशर कमी झालं. आणि इथून इथे जाताना व्हॉल्यूम कमी झालं आणि प्रेशर काय झालं? वाढलं. आणि सिस्टीम इथून निघून इनिशियल स्टेटमधून निघून परत तिथंच आली आणि त्या प्रोसेसला काय म्हणायचं? सायक्लिक प्रोसेस. मग आता बघा, मी तुम्हाला मागच्या लेक्चरमध्ये सांगितलं इंटरनल एनर्जी दॅट इज ए स्टेट फंक्शन. आणि म्हणून डेल्टा यू जर इनिशियल स्टेट अँड फायनल स्टेट दॅट गेट कोइन्साइड अँड देअरफॉर चेंज इन इंटरनल एनर्जी दॅट इज इक्वल टू 0. आणि तुम्हाला माहिती आहे क्यू दॅट इज इक्वल टू डेल्टा यू प्लस डब्ल्यू. आणि डेल्टा यू जर 0 असेल तर क्यू बरोबर डब्ल्यू. आता ही कंडिशन कुठे होती? आयसोथर्मल चेंजला पण हीच कंडिशन होती, क्यू बरोबर डब्ल्यू. म्हणजे ऑल हीट सप्लाइड टू दी सिस्टीम दॅट इज युज्ड टू परफॉर्म द वर्क डन. आणि म्हणून डेल्टा यू दॅट इज इक्वल टू 0 इन केस ऑफ ए सायक्लिक प्रोसेस. आता बघा, एरिया अंडर दी कर्व. आता जाताना एवढं वर्क डन झालं आणि सिस्टीम परत येताना एवढं झालं. डिफरन्स म्हणजे किती येणार आहे बघा, तर एवढा डिफरन्स येणार आहे. मग आता याच्यात मध्ये बघा, जाताना वर्क डन कमी एक्सपान्शन आणि येताना जास्त म्हणजे वर्क डन हे काय येणार आहे? मग आता बघा, ही कोणती हे सिस्टीम आहे? तर अँटी क्लॉकवाईज आहे. सायक्लिक प्रोसेसमध्ये अँटी क्लॉकवाईज असेल तर वर्क डन हे नेहमी निगेटिव्ह येतं. हा जो माशाचा आकार दिसतो, ह्या एवढा जो हे शेडेड एरिया आहे एवढं तिथं वर्क डन घडून येतं. आणि उलट केस जर घेतली आपण, बघा आता जाताना हे वर्क डन म्हणजे हे पॉझिटिव्ह आणि परत येताना हे निगेटिव्ह, तर एवढंच वर्क डन एरिया अंडर दी कर्व दॅट गिव्ज यू वर्क डन. पण ते वर्क डन कसं असणार आहे? पॉझिटिव्ह. म्हणजे क्लॉकवाईज सेन्सने जेव्हा तुमची सायकल असेल तेव्हा वर्क डन हे काय घ्यायचं? पॉझिटिव्ह. परत एरिया, हा माशाचा जो आकार आहे एरिया अंडर दी कर्व दॅट गिव्ज यू दी वर्क डन. अँड दिस इज ऑल अबाउट सायक्लिक प्रोसेस अँड हीट इंजिन दॅट इज द बेस्ट एक्झाम्पल ऑफ the cyclic process. We have to study the heat engine in detail in lecture 3rd, one short lecture part 3rd. Understood? And in this manner we can explain the cyclic process. कळलं? हीट इंजिन हे सायक्लिक प्रोसेसचं बेस्ट एक्झाम्पल आहे. क्यू बरोबर डब्ल्यू, जे आयसोथर्मलमध्ये पण होतं तेच सायक्लिक प्रोसेसमध्ये आहे. चेंज इन इंटरनल एनर्जी इथं 0 आहे. पण कशामुळं? आयसोथर्मल प्रोसेसमध्ये टेम्परेचर कॉन्स्टंट होतं म्हणून इंटरनल एनर्जी 0 होती. इथं मात्र इनिशियल स्टेट अँड फायनल स्टेट दॅट कोइन्साइड मीन्स सिस्टीम रिटर्न्स टू इट्स इनिशियल स्टेट अँड देअरफॉर चेंज इन इंटरनल एनर्जी इज 0. And in this manner area under the work done that is give you the value of work done. And in this manner we can explain the cyclic process. And last, that is free expansion. That is free expansion. Free expansion. फ्री एक्सपान्शन. बघा, जेव्हा एखादं एक्सपान्शन इतकं फास्ट घडतं की सिस्टीमला हीट एक्सचेंज करायला वेळ मिळत नाही, म्हणजे क्यू बरोबर 0 आणि डब्ल्यू बरोबर सुद्धा 0, आणि त्या एक्सपान्शनला काय म्हणायचं? तर त्याला म्हणायचं फ्री एक्सपान्शन. अंडरस्टूड? एक्सपान्शन इन ए व्हॅक्यूम दॅट इज फ्री एक्सपान्शन मीन्स ए पंक्चरिंग ऑफ ए बलून, puncturing of a tire. These are the expansion they are performed in vacuum so that system does not, the boundary is perfectly insulating. System does not get time to exchange the heat, and therefore Q equal to W, that is called as a free expansion. Now we know that Q, that is equal to delta U plus W. When Q 0, W 0, alternately delta U, that is equal to 0. Means Q0, W0 and change in internal energy is 0, and that expansion is called as free expansion. Understood? It is uncontrolled expansion. बघा, जर फुग्याला टाचणी लावली तर तो पटकन काय होतो, त्यातली हवा पटकन निघून जाते. टायरमध्ये खिळा घुसला तर पटकन त्यातली हवा निघून जाते. म्हणजे सगळं ज्याच्यात 0 असतं, डेल्टा यू म्हणजे चेंज इन इंटरनल एनर्जी, हीट सप्लाइड टू द सिस्टम अँड वर्क डन, ऑल आर 0. दॅट एक्सपान्शन इज कॉल्ड ॲज ए फ्री एक्सपान्शन. इट इज अनकंट्रोल्ड चेंज, इट इज instantaneous change so that system does not maintains the equilibrium. बघा, जर प्रोसेस खूप स्लो झाली तर सिस्टीम थर्मोडायनॅमिक इक्विलिब्रियममध्ये राहते, आणि प्रोसेस फास्ट झाली तर सिस्टीम थर्मोडायनॅमिक इक्विलिब्रियममध्ये राहत नाही, आणि ही फास्ट आहे आणि म्हणून थर्मोडायनॅमिक इक्विलिब्रियममध्ये ही सिस्टीम राहत नाही. ओके. आणि सगळ्यात महत्त्वाचं, याची पी व्ही डायग्रॅम आपल्याला काढता येत नाही. फक्त याची इनिशियल स्टेट आणि फायनल स्टेट आपल्याला पी व्ही डायग्रॅमवर दाखवता येते. अँड ऑल दीज आर दी डिफरंट थर्मोडायनॅमिक प्रोसेस. I tried my best. If you understood all this process, then like this video. Then also share with your friends and subscribe my channel so that you will get notified about my new upcoming videos. Okay, thank you very much.